Hi class, in this video I'm going to talk about the degree of a term and polynomial. So if you have a polynomial or expression, the degree of the polynomial or expression would be the highest degree of whatever term you have. So here let's talk about the degree of a term first. The degree of a term is defined as the sum, meaning when you add everything together, of the exponents on the variables of a single term, and the keyword is a single term. Notice how 3b is a single term. For 3b, the sum of the exponents, remember 3b can be equal to 3b to the power of 1. Hence, the degree of my term here is going to be equal to 1. 3b squared, because you have a 2 here, the degree is going to be equal to 2. And 3b cubed, because you have a 3 here, the degree will be equal to 3. Okay, now looking at the degree of a polynomial, once again, the degree of a polynomial or expression is the highest degree term in that polynomial or expression. So looking at this example, I have two different terms in this polynomial or expression, 3x squared plus 1. Hence, my degree of this polynomial or expression is going to be 2 because I have a 2 here, and that's the sum of my exponents. And so the degree is going to be 2. For 7b cubed plus 2b squared minus 7, some students make a mistake of saying the degree is going to be 5 because they add the 3 and the 2 together on the exponents. But you can't do that because you have to remember this only works for a single term. When you find the degree of a polynomial, you're focusing on the highest degree of the term in the polynomial. So the highest degree here would just be this term here. Hence, your degree is 3. And now looking at our fourth example, 3bg cubed plus 2b squared minus 7, your highest degree is 4. And the reason for that is because 3b g to the power of 3 is actually equal to 3b to the power of 1 and then g to the power of 3. Notice my exponents, the 1 and the 3, would add together. Hence, that's why I end up getting the degree of 4. So that's how I ended up getting that degree there. Okay, it's most likely better if I go over some examples. So let's go over some examples here. Here I have 5 rows. Let's go over the first row that's already been done for us. It says the expression is just 24. So that's just a constant. And the number of terms is 1. That is true. And the degree of polynomial is 0. Now, why is it 0? Well, you have to remember, I'll say x cannot equal to 0 here. Any value to the power of 0 that isn't 0 to the power of 0 is going to equal to one thing, just 1. So what's stopping me from saying this is going to be 24x to the power of 0? Absolutely nothing. And if that was the case, because if x isn't 0 and any number to the power of 0 is 1, I would just get 24 times 1, which is still going to be 24. So that's why my degree of polynomial is 0, because there's an invisible x to the power of 0 that can be attached to that 24. And since x to the power of 0, assuming x isn't 0, is going to be 1, I just have 24 times 1, which still equals to 24. And this still satisfies my degree of polynomial because, well, that's the sum of the highest degree of the term that I have. So that's going to be 0 here. Now, y minus 5, the number of terms is 2 because I have one plus or minus sign separating these terms. And the degree of the polynomial is 1 because, remember, y is also equal to y to the power of 1. Hence, that 1 is going to be my degree of polynomial here. Now, looking at my third row, I have 3 terms. So it looks like the first term is going to be my highest degree term. I have 5x squared. Okay, so once again, 3 terms. Since I have x squared, that's a 2 there in the exponents, I'm going to say my degree of this polynomial is going to be 2. Okay, now looking at my fourth row, looks like I have 3 terms again. And my highest degree of this polynomial is actually going to be 3. Because if you look at the first term, that's my highest degree here. Remember, 5x y squared is actually 5x to the power of 1 and then y to the power of 2. So I actually have a 1 and a 2 here. So 1 plus 2 is 3. So my highest degree of the polynomial is going to be 3. And now looking at my fifth row, I have 4 terms because I have 3 plus or minus signs separating 4 different entities. And my highest degree of this polynomial is going to be 3 because 7x cubed, my cubed here is my highest degree term, and hence that's my highest degree polynomial. So I'm going to get 3 there. Now let's go over some more examples. So I'm going to write an expression that satisfies the criteria for each sentence. So here it says a fifth degree monomial with 2 variables. So a monomial means I only have one term. So let's just write something with one term, and I have 2 variables, and the degree is 5. So why don't I just write something such as x squared y cubed? This would satisfy this very simple one, because now if I add up my exponents, that equals to 5, so I have a fifth degree polynomial. It's a monomial because there's only one term, and there are 2 variables, x and y. Now looking at the second row, a fourth degree trinomial without a constant. So a constant is just an entity that we know, so it can be any number by itself separated by a plus or minus sign. So I should just have all variables in this case, and it's a fourth degree trinomial. So why don't I just go x to the power of 4 plus y plus z, right? X to the power of 4 plus y plus z. This is a trinomial because I have 3 terms. The highest degree is 4, and there aren't any constants, so that would work. And now for the last row, a 7th degree binomial with 3 variables and a constant. So if I want 3 variables and it's 7th degree, why don't I go like this? Why don't I just go a, b, c to the power of 5? So this would be a to the power of 1, b to the power of 1, c to the power of 5. So that would be 1 plus 1 plus 5, which gets me 7. And I have 3 variables. A binomial means I have 2 terms. So let's just use a plus sign here and write a constant. Any constant would do. So let's just go 2. So this would satisfy the condition for the last row.